When you have a large number of libraries and software components to work with, it can be overwhelming to manually pick which ones to use along with their dependencies in a project. It becomes even more of a pain when you have to manually edit header files or build scripts to include those components. Kconfig is a configuration system originally developed in the early 2000s to help people build variations of the Linux kernel, which I would consider a pretty large software project. Kconfig's syntax might seem a little antiquated at this point, but it's still used in Linux kernel development, and many embedded frameworks like ESP-IDF and Zephyr have adopted it to help developers choose and configure various components. I'll show you how to use Kconfig to include libraries from the ESP-IDF framework, as well as define your own symbols, which is critical when writing your own components. To start, let's create a new project in our workspace apps directory. So go to new folder, we'll create Kconfig demo. In there, we're going to create a main directory like we did for the Blinky app. And we're going to create a main.c. We'll include standard input-output as well as include the ESP-IDF logging system. We're going to just write a few basic strings to the console, but we'll do it using this logging system. We'll also include the free RTOS header file so that we can get access to vtask delay in order to sleep our super loop. Next, we'll set up our sleep time as our main setting here so that it only prints to the console once every second, and we will also define this string kconfig demo that is the tag for the logs. Next, we will define our super loop, which is just a while true loop. We will printf to the console to show the various levels of logging. We'll start with the basic error level. Notice that we use these functions ESP, log E, log W, and so forth to output the various log levels. We also give it the first parameter of the tag. So in this case, it will be tagged kconfig demo for the logs. This is very useful when you're writing libraries and components. You can keep the tag unique to that particular, say, function, library, component, so you know where in your code this message is being output from. Then we will do the various levels that are available to us in ESP-IDF, and that is from error, we have warning, info, debug, and verbose. We can enable and disable each of these log levels. Note that when we enable one of them, anything that's a priority at that level and above gets printed. By default, info is enabled, so everything that is info, warning, and error messages will be printed. So that's anything that's log I, log W, and log E. But we can also enable more verbose printing, such as these debug and verbose messages. Finally, we'll just sleep this thread for a second. In this main folder, let's create our cmake lists.txt. All we're going to do here is include the main.c, that is our source code, and we will include the current directory, but there are no header files for us to include. Don't forget in main.c to file save your work. And in kconfig demo, above that main folder, we're going to create another cmake lists.txt. We're going to set the minimum CMake required version to 3.16. That's in line with everything else from ESP-IDF, including their examples. We'll also include the build system. This enables all of the extensions that ESP-IDF enables for CMake so that we can successfully build our project. And we will also fix this function call. Then we will give the project a name. In this case, we're just going to call it app, which affects the output of our build system. So the binary name will be app.bin. Save this. And let's bring up a terminal. Let's go into workspace for our terminal. Go into apps and kconfig demo. From here, we need to set our target. If you are curious, you can type idf.py --list targets. List targets. And you can see the available targets for us that ESP-IDF can build for. If you're working with something like the S3, you would put the S3 here as your target. So ESP32 S3. I'm going to be using QEMU for this example, just to demonstrate how this software and logging works. For that, I recommend using the basic ESP32. So let's run that and let it set the target for just a moment. Hopefully you don't have any build errors. From here, refresh your File Explorer in VS Code. You should see a build folder, and that is where everything will be built once we actually build the project. But what we're looking for is this sdkconfig file. you can search for something called idf_target. And here you can see where we set that ESP32. Note that config underscore is the prefix used for all Kconfig symbols. If we search for log default, you can find the default log level, which is set to 3, and that is the info level. We will use menuconfig in a moment to see how to adjust this, but for now, know that ESP-IDF sets the default log level at 3 when you're creating a project. Back in our terminal, let's type idf.py, qemu, and monitor. This is going to build the project and then automatically fire it up in a qemu environment so that we can watch those log levels. Once it's done building, you should see output like this, showing the ESP32 environment running. It resets the processor, the emulated processor, and then you should see your log messages. This is the printf, followed by the different log outputs. So we can see error, warning, and info because that's what level 3 does. It prints these out, the E, W, and I, but it does not print out D and V for debug and verbose messages. Let's stop this by pressing Control close bracket. And let's see if we can adjust that. So idf.py, and we're going to go into menuconfig. Menuconfig is a menu-based interface that runs inside of a terminal like this. It allows us to select and configure various software options. The Kconfig system that is built into ESP-IDF looks at those options and determines which components to include, which libraries to build and link to our application. In addition to enabling and disabling various software components, we can also configure various options like our log level. So if you go into something like component config, you can see the various options here. So Bluetooth, you can press space or enter to go in here, and you can press space to enable or disable these options. So by pushing space, this actually enables the Bluetooth library, and now I can use it in my code. The component in ESP-IDF will be compiled and linked to my code. So let's press space because we're not actually using Bluetooth this time. I'll press escape to go out one level. I'll press escape again, and now I'm back at the top level. You can press / in order to search. So I'm going to search for ESP-IDF target. You can see it pops up here. I'm going to click enter, and I can browse this, and I can press question mark to view information about this particular symbol. You can see it's a string, ESP32, and if I used another variant, this might be ESP32S3. The ESP-IDF system looks for this string to determine which target it needs to build both the libraries and my application for. The one issue here is you'll notice that it's red. It means I can't actually adjust this value manually in menuconfig. You could manually modify sdkconfig, but the reality is it will likely get overwritten. So there's this nice note up here that says it's a generated file, do not edit. ESP-IDF wants you to use menuconfig, but I'll show you how to enable defaults in just a moment. Other ways to set symbols, specifically this one, is to use an ESP-IDF tool like that idf.py set target tool that we've been using to actually set the target, because that does more than just set the symbol. There's other configuration that goes on the back end. You can press A to hide and show those hidden symbols. Let's search for log default level. This is just like the one we saw in sdkconfig. You notice here that it's red as well, so I can push A to hide that or A to show it. If we press question mark, we can see that these values are actually dependent on other symbols being set. So you can see here it's set to 3 because log default level info is set to Y or yes, which means that symbol has been enabled. If we press escape, we can actually set it by going to this option here, default log verbosity. So press enter to go in that, and here's where we can actually set the default log level. No output means show no logging. Errors are just errors. Warnings are errors and warnings. Info, as we saw, are errors, warnings, and info. Let's highlight debug and press space so that now our verbosity is debug level. So that should show error, warnings, info, and debugging messages. You'll notice that the log default level is now set to 4. So we can push question mark, go into this, and you can see indeed level for debug is set to yes, which sets this to 4. So let's press escape to get out of that. You can press escape to go all the way back to the beginning, which takes us to this top level. I can push A to hide those red options. And you can push escape to get out, or you can press Q to just completely quit from wherever you are. It will ask you to save your configuration. Let's press yes to save those changes. Once you're out of menuconfig, refresh your file explorer in VS Code. You should notice that sdkconfig.old shows up, and this is the previous configuration, so it creates a backup automatically in case you ever need to go back one previous version. What we care about is this sdkconfig. These are the current configuration details. And if we search for log default level, you can see where our default level has been changed to 4. You'll notice that if a symbol is enabled, they put equals Y for yes. Equals no does actually mean no. That means the symbol is disabled. However, the convention in Kconfig is to not use this equals no explicitly. Instead, what you'll often do is just comment it out so the symbol is never set. In fact, you'll see these below where it says a commented out, a particular symbol is not set. This allows you to use preprocessor macros in C to say, if not defined, this particular symbol, then you can take some action. So it's either enabled or the symbol is not defined. That's by convention. I'm going to Control Z to get back to our default here because we don't want to actually modify that file. Let's run idf.py qemu monitor again and see what happens. Once that fires up, you'll notice that you'll get a lot more messages during boot, and you should see your log messages printed with error warning info, and newly added is this debug message. Let's press Control close bracket to exit. I mentioned earlier that we can generate defaults. sdkconfig and sdkconfig.old are generated. You don't want to modify them, and in many cases, you don't want to check them into version control. You often want to add these two files to an ignore list and let the user or developers recreate them when needed. But if there are specific things like you use Bluetooth in your application and you want that library to be configured and enabled by default, then you want some defaults. The easiest way to do that is to use the save def config for default config option in idf.py. This tool looks at what changes were made in sdkconfig and creates a .defaults file for us. So if you look at this, you can see how we are setting that log level by default here to that debug level. You can indeed set a default target here, such as setting IDF target to ESP32 or say your S3. This will tell the IDF build system that you want to build for this target unless specified otherwise. In most cases, I don't actually like to set this as a default. I like to create applications that can be run across multiple variants. So we'll just keep it as is, save it like that. And when you make changes or create a defaults list like this, it's a good idea to clean up your build directories. So that means removing sdkconfig, sdkconfig.old, and your build directory. So those have been removed. If I refresh my files, these are the things you would want to check into a repository. So definitely keep your .defaults, but get rid of any of the other generated files, like sdkconfig or your build directory. Now, when a user gets this, what they would do is idf.py set the target that they would want. In this case, I'm going to use the basic ESP32 since we're building this for QEMU. And then you could call idf.py build to actually build the program to flash it to your device. Or, in our case, I'm going to build it for QEMU, run it, and go into monitor mode. Once again, your device should boot. And with any luck, we should see the log messages, and we should have debug enabled by default because of what we set in this sdkconfig.defaults file. If you'd like to learn more about this Kconfig system, specifically as it relates to ESP-IDF, head to the project configuration page in the API reference for your particular version of ESP-IDF and your particular variant, in this case, version 5.4 and ESP32. Here they walk you through the process of creating this .defaults file that we just did. Note that you can set target-dependent defaults. If we click this link for custom defaults, you can see that once sdkconfig.defaults has been created, ESP-IDF will look for that. And then from the target that you have set, it will look for another file called defaults.esp32 for that particular variant. This could be ESP32S3 and so on. This is useful if you have specific settings for your different variants. For example, maybe some have 1 core, some have 2 core, and you use those cores differently in your code. Now let's see how to create custom symbols using Kconfig. Let's stop our log messages with control close bracket. And to create our custom symbol, let's close down our work so far. And instead of apps, we're going to create a custom component. In our workspace folder, let's create a components directory. And we're going to name our component Say Hello. This is just a really basic library. In here, we'll have an include directory. This is our header file. So in that, we're going to have sayhello.h, as that's the name of our library. We'll do our header guard, and we'll define our single function that's just say hello. That's just going to print hello world to the screen. We will close out our header guard and save that. Instead of an src or source directory, we're going to put our source code right in say hello. Looks like it didn't quite go in there, so I'm going to drag it and just say hello. Yes, let's move it. I've noticed that in ESP-IDF, if you go into their components, a number of their components are organized this way. Some have src directories, some don't, where they put the source code just in the directory there and then have their header files in an include directory. So we'll mimic some of that here. We'll keep our source code right here, and in sayhello.c, we will first include our standard input output, and we'll include our say hello header file. All say hello is going to do is just print hello world to the console. Let's save that. Notice that the header file sayhello.h is not referenced into the include directory, so we're not doing include/sayhello. We're going to have CMake figure out where that is for us. In the sayhello directory, let's create a new file. We're going to call this cmake lists.txt. And we're going to set two variables. We're going to set the first one called srcs for sources. We're going to append our sources to this list in just a second. Next, we're going to set our include directories. This is another variable, and we're going to tell it where to find those header files. In this case, it's in the include directory, so that's why the include string should match your include folder over here. In a moment, we're going to define a custom Kconfig symbol called say hello. Remember that Kconfig symbols are prefixed with config underscore. And in this case, if that say hello symbol is enabled, we're going to add the source file to that source's variable. To do that, we will call this list function. We will say append to a list. We'll give it the variable srcs for sources, and we'll tell it where to find that actual source code, which is in that same directory, sayhello.c, and we will close out that if statement. We then call this IDF component register function. That's part of ESP-IDF. It's a unique function to the ESP-IDF system. We're first going to tell it where to find the sources for this component. And remember that in ESP-IDF, a component is basically a library. The source code for this component can be found in the srcs variable, which is just a list of source files. In this case, all it contains is sayhello.c. And that's assuming that the sayhello symbol has been enabled in Kconfig. And then we will also set the include directories, which once again comes from this include dears variable. The variables are expanded using this $sign and the variable name enclosed in curly braces. With that, let's save this CMake file. Now to create our custom Kconfig symbol, we're going to create a new file in sayhello, and this file will just be called Kconfig. Notice the capital K and then lowercase config. The naming is important here because ESP-IDF will look for this in order to define these symbols. In this Kconfig language, comments are given by the hash or pound symbol. We will define a new symbol with this config space and then the name of our symbol. Notice that it is in all caps here. This will create a new option in menuconfig when we do this. We're also going to set the type of the symbol. In this case, it's a Boolean, so yes or no, on or off, enabled or disabled. And we will give that symbol a description which comes after this type right here. So basic print test to console is the description of this symbol. Next, we will define the default. It can be Y or N for yes or no. In this case, we will want to have this symbol be disabled by default. Under help, you can give some more information to the user, especially when they're in something like menuconfig. Here, we're just going to say it adds this particular function to print a message to the console. Let's save that, and we have defined our custom symbol. Remember that config underscore say hello becomes this new symbol that we can access in CMake and C and C++. So when we enable it, this if statement becomes true, and now we actually include this source code. If the symbol is disabled, this source code is not included, and compilation will fail if you've tried to include this library and use this function. Right now, when we build a project with ESP-IDF, it will look in the components directory within ESP-IDF by default. That's where it looks for components. So you're welcome to fork ESP-IDF and put your custom components in there. Otherwise, we need to tell it where to find our new custom component. In this case, it can be found in this components directory. So in our Kconfig demo, we'll need to go to CMake lists, and underneath this include ESP-IDF build system function, we're going to tell it where to find our custom components. We're going to use that same list and append function that we saw earlier. We're going to give it the name of the variable. In this case, ESP-IDF has this special variable called extra component dirs, which is a list of directories for where to look for external or third-party components. In this case, we're going to go up 2 directories. So in workspace, we're going to go into components, and it's going to look for components there. By default, the name of the component is the name of the directory underneath this top-level components folder. Let's save that, and we're going to go into our Kconfig demo main and make a couple of changes to it. First, we're going to include sayhello.h. That is our header file that is here. CMake and ESP-IDF will know where that is, so we don't have to give a relative path location to it. Since we've included that, let's come down here, and we will call the sayhello function right after we print out our log messages. So let's save that, and let's run qemu in our terminal. Give that a moment to build, and you'll notice that it actually fails. If you look at the error messages, we have undefined reference to sayhello. That is because in our CMake lists.txt in the sayhello library or component, we said to only include the source file if sayhello was enabled. And remember, it's disabled by default. That means we have a declaration of a function here, so our main application says this function exists, but there's no definition for it because this file, the sayhello file, never got included in the build process. There are many ways to handle this. The first, obviously, is to enable that symbol to get this to compile. But let's say we want modular code where it can work with and without the symbol. Remember that the symbol is defined in C and C++ as config underscore and the name of our symbol. So we can actually access that in our code here. We can say if def config sayhello. If that symbol is defined, go ahead and call this function. Otherwise, don't include this function call in the build process if that symbol is not defined for us. So let's save that, and let's try to build again. Once it builds, you should see it printing, and you can see the error messages that we have configured, but there is no hello world, and that's because this is not included because sayhello is not defined. So let's control close bracket to get out of qemu, and we're going to call idf.py menuconfig. This should be by default in component config because that's where ESP-IDF puts component symbols. So scroll all the way to the bottom. Usually this is where it appears. And sure enough, there is our option, basic print test to console. So press question mark if you want to see more about it. The name of the symbol is sayhello as we set up. And you can see how our help information, type, and default show up in menuconfig here. So you can use the arrow keys to scroll up and down, and you can even see the source code of how we wrote that Kconfig file. Let's press escape to get out of that. Press the spacebar to enable that function. Press Q to exit and Y to save. And we're going to try to build and run it on qemu one more time. Hopefully that compiles and starts running for you. Sure enough, you can see our log messages being printed to the console along with this brand new hello world. Let me scroll so I can stop the automatic scrolling here. Here are the log messages and hello world that's being printed to the screen as a result of this sayhello function. I hope this helps you see how to use Kconfig, use menuconfig to enable, disable, and configure various options, along with creating your own symbols and how that can be used to create modularized code. Don't worry if Kconfig is still somewhat confusing. We'll continue to use it throughout the next few videos, especially as we start working with more complex libraries like Wi-Fi and MQTT. If you enjoyed this video or found it useful, please click the like button. And if you want to learn more about writing firmware for IoT devices, I recommend checking out my online course. We start with the basics of ESP-IDF for writing professional code for the ESP32. Then learn how to read from connected sensors and transmit that data over Wi-Fi using HTTP REST API calls to an IoT platform. We'll also tackle publish-subscribe mechanisms with MQTT before seeing how to secure everything using Transport Layer Security, or TLS. By the end of the course, you'll have the chance to build a full IoT sensor that publishes data to an MQTT broker, and you'll earn a digital certificate to showcase your new skills. Click on the link in the description to sign up.